Ensoftec's HydrologyVA is an engineering tool, which provides computations for the different hydrologic methods used in the Commonwealth of Virginia. In this video, I shall show you the Rational Method Design module. I click on Rational Method. This opens the Rational Method Design folder. At the top, you will see a pull-down list of all counties and the principal cities in the Commonwealth of Virginia. This list is taken from column 1 of Appendix 6E2, giving B, D and E factors defining the intensity, duration, frequency or IDF values to be used in the rational method. These values use the NOAA Atlas 14 precipitation frequency data. It is therefore important to make the county selection if the designer wishes to use the IDF curves. I can select the units, English for the United States customary units or metric for standard international units. Below the county or city field is the number of subareas field, where I can select the number of subareas for each type of land use within the drainage area. Appendix 6E1 of the Drainage Manual gives descriptions for the land use types and their corresponding runoff coefficient values. I can select up to 10 subareas. Let me select 4. This opens a table of subarea description, corresponding area, A in acres or hectares, C range, the applicable coefficient, C and the product of A and C. The number of rows in this table correspond to the number of subareas selected. To the left of each row is a Help button. Clicking on this button opens the subareas form, which is the same as Appendix 6E1, excepting the last row Other Areas. This row helps the user to enter occasional off-site areas draining to the basin and its corresponding C value. When I select the type of drainage area in this form, I am returned to the main form with the selected type of drainage area and the corresponding C range populated in the selected row. I fill in the subarea and the coefficient C fields. If the C value is outside the range shown, the field defaults to the lower or upper value as appropriate. I repeat the steps for all the 4 subareas, and click the Accept button. This calculates CA for each subarea, total A, total CA and the weighted C value. I can always click on the Clear button to restart the above steps. Note that while the recommended drainage area for rational method is 200 acres, in low-lying tidewater areas, where the terrain is flat, the rational method can be considered for areas up to 300 acres. No error message therefore appears even if the area is greater than 200 acres. The next step in the design process is either to directly input, or to compute the rainfall intensity. The first method would not require the use of IDF curves. In this case, I click on Yes Radio button at the bottom right, and enter the 2-year, 10-year, 25-year, 50-year and 100-year rainfall intensities in appropriate units, inches or millimeters in the left bottom fields. I then click the Compute Discharge button. The peak discharges are calculated, and are populated in the bottom left row. If the rainfall intensities are to be calculated using the IDF curves applicable for the county or the city selected, I will need to calculate the time of concentration. For most drainage areas less than about 200 acres, the time of concentration or TC will normally be comprised of overland flow, channel or concentrated flow, and flow in man-made structures such as channels and pipes. You will note these flow types are shown at the top right with a Help button to the left of each. When I click on the Help for overland flow, a new worksheet opens to show the 2 procedures for calculating overland flow: V. Preferred CLE method and the kinematic wave formulation method. The determination of the appropriate rainfall intensity using kinematic wave method is an iterative process with 2 variables, rainfall intensity and time of concentration, being known at the beginning of the computation. The program automatically addresses this process while deriving the time of concentration. I can compute TC using either or both methods and select an appropriate overland flow time. Once this field is entered and the Accept button is clicked, I am returned to the main folder with the selected TC populated in the TC field for overland flow. I repeat these steps for channel flow using Kirpich method, regular channel and pipe flows as required. Kirpich method is limited to defined swales, ditches and other natural channels only. For channel and pipe flow conditions, the user can key in the velocities instead of depth of flow or diameter of pipe respectively. I next click on the Compute Discharge button. The program calculates the rainfall intensities for the 2-year, 10-year, 25-year, 50 and 100-year storm events based on the IDF curves for the particular county or city using the equation I is equal to B over TC plus D raised to the power of E. Note that if the total time of concentration is less than 5 minutes, the program defaults to a minimum flow time of 5 minutes. The rational method requires an adjustment for use with larger storms by multiplying the right side of the formula by a saturation factor, CF. The product of CF and C should not exceed 1.0. The peak discharges are calculated, and are populated in the bottom left row. I can preview and print the results either as PDF file or send to printer. Exit will close the rational method folder. This completes the rational method module.